This is Chapter 4, Linear Correlation and Regression Analysis. This chapter will take 2 lectures, and this is the first of the 2 lectures. Okay, correlation and regression. Correlation is a technique that measures the strength of the relationship between 2 continuous variables. So let's remember what 2 continuous variables could be. If we measure the relationship between people's heights and their weights, we're looking at 2 continuous variables, height and weight, and we're measuring the strength of the relationship. And we're going to do this using a numerical tool. A chart that defines a person's ideal weight for a given height is constructed through the statistical technique called regression. Regression is a statistical technique that produces a model of the relationship, which is a correlation, between 2 variables. So heights and weights would be a great example of what we can do with regression. Linear correlation. Why do we want to know if there is a relationship between 2 variables? So here are some questions that we can ask and can be answered by doing linear correlation. Is there a relationship between a person's income and their intelligence? Is there a relationship between a country's food supply and the country's mortality rate? Is there a relationship between the average length of schooling for citizens in a country and the country's life expectancy? Okay, so we could ask these questions, and by conducting a regression analysis, we can measure the strength of the 2 variables, and by measuring the strength of the 2 variables, we can come to a conclusion on whether or not the relationship is strong, weak, or in the middle, and we can make a conclusion based on the numbers. So linear correlation will help us define or determine if there is a relationship and how strong or weak the relationship is. Okay, we're going to get started with a concept called the scatter diagram. Let's suppose that we have a sample of 12 randomly selected females attending Nassau Community College, and for each female we measure her height and weight. Height and weight are the 2 continuous variables that we're going to work with in this problem. The height will be labeled as variable x and the weight will be labeled as variable y. For each female, we have a pair of numbers, height and weight. So we have this ordered pair, x and y. The pair of numbers can be written as parentheses x comma y, which is called an ordered pair, which you may have seen before if you've studied graphing in algebra. So if you're looking at ordered pair 63, 123, you could interpret this as meaning the student who is 63 inches weighs 123 pounds, because the first variable represents x, the height, and the second variable represents y, the weight. Okay, so this is the chart. It's from your textbook, table 14.1. The female student number is not should not be considered part of the data. It's just an identifier. Okay, the female student number could be used. It could be letters, it could be numbers, it could be n numbers, it could be names, but it's just a unique identifier. So it's not part of the data. The data is in these 2 columns, x and y. We have the continuous variable height, it's measured in inches, and we have the continuous variable weight measured in pounds, and we have the values associated for each of the 12 females. Okay. Okay, a scatter diagram is a graph representing the ordered pairs of the data on a set of axes. Okay, so you should have heard at some point in your math studies what axes are. They're vertical and horizontal lines that basically guide a graph. The 2 lines a horizontal and vertical line represent the two axes. The x-axis is the horizontal line. It represents the x values, which are the heights. So we're going to label the x-axis as height. And the y-axis, the vertical axis, will represent the y values, which are the weights. So we'll label the y-axis as weight. Okay, so this is how we start. Horizontal axis with heights, vertical axis with weight. Notice the jagged line on the horizontal and the vertical. This is there to indicate that we have a lot of space between 0 and the first number on the horizontal, which is 58. So we have our jagged line on the horizontal. And there's a lot of unaccounted space between 0 and 100, which is our first number on the vertical. So we have our jagged line on the vertical. So you could do that. You could do a jagged line on the horizontal and the vertical if the graph warrants it. We start at numbers that are below the majority of the numbers, so we want to capture the entire range of heights. That's why this graph starts at 58 on the horizontal axis and ends at 72. So every one of the data values is accounted for. Weights start at 100 and end at 200, so every one of the weights is accounted for. Okay, the ordered pairs are going to be constructed on the graph using dots. For each ordered pair, we're going to identify the height on the horizontal, then we'll identify the weight on the vertical, and then we'll make a dot for that particular female. Okay, so 62, 123, the first female in the sample. We go to 62 on the x-axis and 123 on the y-axis. Okay, so we go along the x-axis to approximately 62. We go up to approximately 123 on the y-axis, and we make a dot which represents 62, 123. And you can see this scatter diagram has now been completed for the rest of the sample. You could count how many dots you have here. Each dot represents a female in the sample, so we should have exactly 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so exactly one dot per female in the sample. And that is a completed scatter diagram. So if we look at the finished product here, and here's height and here's weight, we can ask the question, do you think that the scatter diagram shows a relationship between a female's height and her weight? Now, the answer is yes. Okay, visual inspection of the scatter diagram can help to determine whether there is an apparent relationship, which is a correlation, between the two variables and what type of relationship it is. There are three basic types of relationships we'll encounter: positive, negative, and no linear correlation. Okay, so let's go back to the image again of that scatter diagram. It's not a perfect line. Okay, perhaps some of you would think that in order for there to be a relationship, you'd need to have the dots grouped in a perfectly straight rising line from left to right. These dots are not. They are scattered a bit. However, they're not entirely random. Okay, imagine if you just took marbles and you just dropped marbles on the floor. They would go in all different directions, and that would be completely random, and that would indicate no correlation, when there's absolutely no relationship between the dots. But if you look here, we do have lower weights corresponding to lower heights. And over here we do have higher weights and higher heights. So even though it's not a perfect relationship, there is somewhat a grouping that groups the points in a way that they rise from left to right as we move across the graph. Okay, so we're going to look at the positive correlation, negative correlation, and no linear correlation.